Good morning, students. This is our lecture number 2. In lecture number 1, we have discussed the geometrical concept of the derivative. Today, in our lecture, we will discuss how to find the derivative of some fundamental functions. Before that, we have to look some basic formulas given here. These are the formulas we have to remember. Derivative of x is 1. Derivative of ax, a being any constant, then derivative of x will be a. Derivative of x to the power n is n x to the power n minus 1. Derivative of ln x is equal to 1 upon x. Derivative of e to the power x is itself e to the power x. Derivative of a to the power x here. Derivative of a to the power x, a may be 2, 2 to the power x. Derivative of 2 to the power x is equal to 2 to the power x ln 2. Similarly, we can apply this formula here also. E to the power x ln 2, but ln 2, sorry, e to the power x ln e. Ln e is our 1. So, result is d to the power x. Okay. Derivative of sin x is equal to cos x. Derivative of cos x is equal to sin x. Derivative of cot x is equal to minus cos x square x. Derivative of tan x is equal to sec square x in sec x. Derivative of sec x equal to sec x into tan x. Cosec x equal to minus cosec x into cot x. Sin inverse of x is equal to 1 upon under root 1 minus x square. Derivative of cos inverse x is just negative of sin inverse of x. That means minus 1 divided by 1 minus x square under root. Tan inverse x, derivative of tan inverse equal to 1 by 1 plus x square. Derivative of cot inverse x is the only negative of tan inverse f x. And derivative of sec inverse of x is equal to 1 by mod of x under root x square minus 1. And last one is our derivative of cosec inverse of x is equal to minus 1 divided by mod of x under root x square minus 1. These are the basic formula we have to remember. Then we can do various problems. Today we will discuss chain rule. Before going to chain rule, we should know the some functions like composite function. What is composite function? Let suppose fx is equal to sin x, and we have to find the derivative of fx. It is easy to find f dash of x equal to cos x, no doubt. Similarly, another function suppose given g of x is equal to e to the power x, and we have seen this formula of derivative of e to the power x. That means g dash of x is equal to e to the power x itself, no problem. But if a function is given like this, e to the power sin x, how can find the derivative of this function? And this function is a composite function. How? Let's to find f of g of x. This is called fog of x. Fog of x. And f of g of x is equal to f. And gx is given here e to the power x. Is equal to f of g of x. Now f of e to the power x is just replace e to the power x in the place of x. That is sin e to the power x. This is fog x. Similarly, we can find g of x. G of x is equal to g of f of x is equal to g of f of x is given sin x is equal to, now replace sin x in place of x, and g of x equal to e to the power x, so e to the power sin x, right? If function fx gx is given, then corresponding to that function we can evaluate derivative. But if the composite function is given, these are all composite functions, how can we find? Here we have to find, here we have to remember that what are the root function? Root function, the basic function here is e to the power x. What we have putting in the place of gx? simple root function e to the power x, and here sin x. Keep in mind the root function. What are the root functions? I'm telling you the root functions are the functions whose derivative already known before. We have discussed sin x, cos x, e to the power x, 1 by x. These are called basic function or root function, you can say, to understand the chain rule only. Okay. Now start. What is chain rule? Chain rule. Suppose y is equal to given f of g of x, right? Then dy by dx will be f dash of x into g dash of x. F dash of x into g dash of x. Or conveniently, let g of u is equal to g of x. If we substitute g of x, keep in mind g of x is root function here. To understand only chain rule, exactly not root function. I'm telling you to understand the chain rule, okay? Root function whose derivative already known to us. Okay. U equal to g of x, then y is equal to what? F of u, right? Then dy by dx we have to find. So here y is a function of u. So dy by du into u is a function of x. So du by dx resulting to dy by dx, right? If this will cancel, then dy by dx will be remaining term. This is our result. Okay, let's do some example. Let's take same example. Y is equal to e to the power sin x. It is important find the gx for the basic function, the root function, whose derivative we already know. Okay, here e to the power x. Here e to the power x, where is sin x in the place of x. But if we analyze here, the sin x is the root function. According to our for our understanding, we can take sin x equal to u. That is u is equal to sin x, right? Then y will be e to the power u, right? Now to find dy by dx, dy by dx will be dy by du into du by dx. Because y is a function of u here, and u is a function of x here. So derivative y with respect to u and derivative u with respect to x. Okay. So dy by du will be e to the power u. Derivative of e to the power u is itself e to the power u into du by dx. That means u is a function of x. Derivative of u with respect to x, sin x. Sin x. Derivative of sin x is cos x. This is our result. E to the power u. Substitute the original below q. What is u? Is equal to sin x into cos x. That means dy by dx is equal to e to the power sin x into cos x. Try to understand what we have done here. Given y equal to e to the power sin x. First of all, we have to guess what is u. First of all, treat u to that function whose derivative you know. Okay. Here we do not know the derivative of e to the power sin x, but we know derivative of sin x here. So u is equal to sin x. Then y will be e to the power u. Then dy by dx will be dy by du into du by dx. Okay, we're taking another example. Let y is equal to sin x cube. Sin x cube. What is your base function or root function? Or which function have derivative? We have already known before. We know the derivative of sin x, but we don't know the derivative of sin x cube. Try to understand. We know derivative of sin x is equal to cos x, but we do not derivative of sin x cube, so we can take u is equal to sin x cube. Rather than we can take x cube is equal to u, right? because we know the derivative of x to the power n. Derivative of x to the power n with respect to x is equal to n x to the power n minus 1, right? So y will be sine u. Now to find dy by dx, that means dy by du into du by dx. So put the value of dy by dx, that means y is here. So find dy by dx. Dy by dx equal to sine derivative of sine, that is cos u, into derivative of u with respect to x, that means 3x square, n into x to the power n minus 1. That means 3x square into cos u. And substitute the place of x square. Got my point? This is a process how to find the derivative of a composite function. If a simple function like sin x cos x e to the power is given, then easily you can find by using the formula, direct formula. But here we are using that formula, but in different ways. Okay. Okay. Next example. Suppose y is equal to e to the power root x, e to the power root x. What is our u here? Let's take u is equal to root x. Root x is what? Root x is x to the power half. That is the formula we have to use, x to the power n. That means here u is equal to root x. If you will take, then y will be e to the power u. Then dy by dx is equal to dy by du into du by dx. Dy by du, that means e to the power u. Derivative of e to the power u is itself, and du by dx, x to the power half. Derivative of x to the power half is n. N is your half. Half into n into x to the power n minus 1. Half minus 1, that is 1 by 2 into x to the power minus half, right? So 1 by 2 x to the power minus half is equal to e to the power u. What is u? U is your root x into 1 by 2. We can write 1 by x to the power half, bringing to denominator, and this will be 1 by 2 root x e to the power root x. This is your root x. X to the power half is your root x. So 1 by 2 root x e to the power root x. Okay. Now do some another examples. This is very important. Let y is equal to sine of e to the power cos x. Look at this function. Here we have to find u. What is our u? If we take cos x is u, because we know the derivative of cos x. Simple. So u is equal to our cos x. Then we have to take another variable, v is equal to e to the power u, and last y is equal to sine u, because here three functions are here: sine, exponential, and cos function. Three functions are here. So we have to derivate this function piecewise, one by one, one by one. First of all cos x, then exponential function, then again sine x, sine function. So we have to take that variable, we have to increase such variable according to the given function. In previous example, we have given only two functions. So we are taking u is equal to something, and then y is equal to something, and then we applied chain rule. But here sin x, exponential function, cos x. In this expression, total in this expression, we know the derivative only cos x. So u is equal to cos x. Then preceding this one, then we can write e to the power u is equal to v, again sine u is equal to u. Why? Then dy by dx we have to find. Find the dy by dx is given. Find dy by dx. Look at this. Very interesting. Dy by y is the function with respect to u. So dy by du into du. Sorry, this one is v. I did a mistake. This one is v because e to the power u. This expression we have taken v. So sine v is y. So dy by dv and dv again v is a function with respect to u. So du into du with respect to dx. So dy by dv is your cos t into dv by du is our e to the power u. Derivative of e to the power u is e to the power u into du by dx is minus sin x. You know the derivative of cos is equal to minus sin x. So minus sin x into cos v, cos of e to the power, substitute v. What is v? V equal to e to the power u into e to the power u. Now again substitute u minus sin x cos of e to the power u is our cos x into e to the power cos x. So the result is your minus sin x e to the power cos x into cos of e to the power cos x. This is our result. According to the given function, we will take u, v, w, x, okay, for our convenience. We will take such variables and derive the corresponding function with respect to given variable. That means y here we have to find dy by dv, not du, dv, because y is a function of v, v is a function of u, v is a function of x, and at last we have to find dy by dx. Clear? At last we have to find dy by dx. So this is the chain rule. How to find derivative of the composite function. Okay. In the next lecture, we will discuss how to find the derivative of a function which are multiplied. Two functions are multiplied or three functions are multiplied. Similarly, if two functions are divide each other like this, if sin x by x, how can we find this derivative of this function? By using division formula and multiplication formula, product rule. We will discuss in lecture 3. So thank you all of you.